son's computer. All right, so I'm going to pass it off to Dr. Linkhart now. He will wow us with knowledge. It's basically just a microphone for people online to hear. Okay, so if you can just look at it. I haven't tried this, but I would.
Pointer and advance, or
It should be advanced, but doesn't seem to want
okay. I can advance back here if need to. Let me try that one more time, maybe. Well, I don't know about that. Oh, really? Gotcha. Yeah. No. Batteries are good. I take it? Yeah. Okay. Well,
I can be your slide adventure.
once you have it, I'll be fine. So sorry.
Sure, sure.
Down arrow or?
For those online, we'll be right back. Let me make sure I share the right thing. There's a possibility that I did not. That was probably the problem.
Ah, well. It looks like that's the deal right there.
I blame the babies.
No worries. Not a worry. Hi, everyone. Thanks for being here tonight, and happy to see some familiar faces from last times and new faces certainly as well. Regardless, this is a topic I always enjoy talking about and have for a long time. So I'll share tonight some aspects about this migration work that I've been doing. And for starters, maybe I'll show you a couple of the units I'm going to be talking about. So those of you that are fortunate to have seen or heard flammulated owls before, how many of you have heard or seen? Oh man, a lot of hands. That's cool. So small enough to fit in the palm of your hand, okay? Second smallest North American owl for sure, right behind elf owl. Probably the second smallest owl in the world from what we know of about the 200 species or so. So my students long ago started telling me, or at least the crews that were snacking on Oreos, that a flammulated owl weighs less than 5 Oreo cookies, okay? So ever since, that's been my reference point anyway. 50 grams or so, but 5 Oreos might be fewer than 5 Oreo cookies might be the take home. So this is one of the GPS units I'll be talking about here, okay? It's about the size of a dime. I'll have another picture of it in a slide in a moment, with about a 2-inch antenna on it. And this is another unit, different, at least in terms of its function. This is a geolocator, it's called, or a light level logger, it's also called. This works by a different principle, but again, each of these weighs about 1 gram, okay? And if a flammulated owl weighs about 50 grams, this weighs only about 2%-ish of the weight of a flammulated owl. And I'll show you a couple shots as I get going, but just to model, These are mounted on the back. Owls will carry them as a backpack unit on the back. And I use a very thin fishing line, a 20-pound fishing line. Here's one that's been to Mexico and back, and this is the remains of the harness after, I think this was on the bird for about 2 years, actually. So that's what it looks like after it's been broken in, after a couple of years. Anyway, afterwards, you're welcome to come up and look at these. Want to introduce a few things as I get going here. One is, let me tell you a few additional things about flammulated owls. And this work has been going since the early 1980s, since I was a young undergraduate at Colorado State University, actually, is when I started doing some of the work on flammulated owls. So I want to tell you some things as backdrop about what we've learned about flammulated owls over that time, because it sort of establishes a foundation for understanding what's going on with the migration work as well. Can everybody hear me okay? Okay. So flammulated owl, flammulated is Latin for flammula, and flammula means small flame, okay? And their facial disc, you can see a lot of orangish red plumage on the face. That certainly is the namesake for flammula. You'll see some other pictures where you see some of the reddish orange plumage on their back, especially on their scapulars as well, okay? This is a highly camouflaged color, and the males who during the summer they don't roost inside of cavities, the males don't, only the female and the young will remain inside of a woodpecker cavity where nesting is happening. Otherwise, the male roosts out in the open. And so no doubt there has been high survival value on flammulated owls, especially males, being the coloration of bark on ponderosa pine trees, which they primarily roost against. And the older, some of you may know this, the older ponderosa pine trees get, the orangier the trunk gets. And so flams are adapted to live in these forests, and certainly against the trunks of these older ponderosa pine trunks as well. Students, I'll be talking about we a lot in the course of this, because the students at Colorado College that work with me during the summers, and students that are in some of my classes for sure, do a lot with this owl, at least in the time before they do migration. But during the summer season, the students are a really important part of the work that I'm going to be describing here. And it does take a small village to study this species and to be able to make progress on things that we've been studying here for a long period of time. So when I started work on flammulated owls a long time ago, there wasn't much known about them, as was referenced in the beginning here. We knew that some of the few flammulated owl nests that had been found in pine forests, especially in ponderosa pine forests. These range maps, I'm going to come back to this here in just a moment. You see the range map for flammulated owls at the bottom. Approximately, we don't know the exact boundaries even of all of the forests that they're in. But look at the map on the left of ponderosa pine for a moment as well. So we knew it from a long time ago that owls have been associated with these forests, but not really knowing how deeply the association was, or exactly what aspects of the life cycle might be involved in that forest type. But the work that has happened now by students and me have definitely substantiated that ponderosa pine, especially in the Rocky Mountains, but throughout the western U.S., ponderosa pine forms the overstory of a very important forest type in the life history, the breeding habitat of flammulated owls. And if you needed any more convincing of that, look at the range map of flammulated owls here in blue, and look at the range map of ponderosa pine on the left. It should look as though you can pretty much transpose one on top of the other. And that is very much the tight association that flammulated owls have in this habitat. Early on, and for the last many years, even before I started the migration work, you can see this area in Central America that was suspected to be possibly an area important for flammulated owls to migrate to, okay? And some places in Mexico as well. But nothing had been known about the migratory status of flammulated owls until just, 2016 is when students and I published the first paper documenting exactly where they migrate to. And prior to that, it had all been supposition in terms of the particular locations they might migrate to. Still a lot to learn, as I'll be telling you about, but we're making headway with that as well. It had been known, at least for the few nests that had been found, even in the early 1980s, the owls are secondary cavity nesters, meaning they secondarily require cavities that are excavated by woodpeckers, especially northern flickers, but they will use cavities from smaller woodpeckers, including the hairy woodpecker and red-naped sapsuckers and Williamson sapsuckers in ponderosa pine forest. But usually those require a little squeezing. So the northern flickers are the preferred cavity. But they are requisite cavity nesters. So this is a really important association here, a really important aspect that they have evolved into. Like other species that are secondary cavity nesters, they could not breed, they would not exist without having this resource available. And so this is one of the reasons for their association with older forests, but not all, okay? So long presumed to be a neotropical migrant, meaning, for those birds that nest in the United States, the Nearctic region, it's been thought that these birds would migrate to Central America, maybe even further south, but no justification for it. Aspects that we had fallen onto as evidence for migration in the past were a lot of indirect evidence, including fall vagrants. I mean, there had been occasion, and I still receive some contacts from people in the Gulf area of Mexico, off the coast of Texas and Louisiana, where strong storm systems may move through during migration time, and flammulated owls get stranded on oil platforms out in the Gulf in places. And that's off their migration route that I've been learning about. And certainly flammulated owls are not found in that part of the world, or at least at the southeast coast, for breeding purposes either. So some pretty interesting things that happen normally with any of the long distance migrants that we know about, certainly with songbirds, warblers and thrushes and so forth. We can see vagrancy in that sense as well. Well, on the basis of these habitat associations, long distance migration status, and the aspects of being secondary cavity nesters, the owl has been identified as a species of protection by the US government and the US Fish and Wildlife Service for a long period of time, and certainly by the Canadian government as well. That was originally part of the impetus for me getting involved in owl work, but I figured it was just going to be fun stuff from the very beginning anyway, and it always has been, for sure. So to date, there are 5 areas within the state on which students and I study populations of flammulated owls. And I also do some work on the species in New Mexico and Arizona. But there's not quite time enough to spend that degree of effort in those states as I do here in Colorado. It's this area here on the Hotel Gulch that is the original study area that is still really important in the research efforts that happen during the summer. And so the migration devices that I told you about, they have been attached to owls on all of these study sites, but especially the Hotel Gulch and Missouri Gulch study areas, okay? Well, let me give you a feel for what a summer looks like in terms of being a undergraduate researcher or Linkhart in terms of studying flammulated owls. It always starts very similarly because and by the way, there are multiple projects going on with flammulated owls every summer, okay? Many that have gone on really since the 1980s. Some of them have finished, new ones have popped up, but some of the projects, especially in looking at habitat associations and long-term demography, reproduction, and survival patterns have been projects that will probably go on as long as I can do it. But these aspects have required these study areas on which to study the owls, and the beginning of every every field season begins the same way, in that the owls have returned to Colorado to breed in my study sites, and it's time for my students to get out as soon as we can in May to be able to find where those owls are, to document where the males have settled into their territories, which males have been successful or not in attracting a female to breed with. Not all males are. Some are destined to be bachelors. And then trying to figure out where the nests are so that we can figure out how many young there are, how many owlets are in the nests, so that ultimately we can capture and band every single flammulated owl on the study sites, okay? That means breeding males and females, that means owlets. That also means floater individuals that are not old enough to have a territory yet, and are actually sort of like teenagers of the flammulated owl world, and they are hoping to, become old and mature enough to be able to defend a territory at some point in their lives. We want to capture every one of those is the goal, so that we can track the reproduction and survival of every single individual through time. And that has required, the 40 years plus now to do so, because these owls, it's turned out, have pretty long lives. So every spring we go out at night to mimic the call of a flammulated owl. Oh, it's time to teach you how to call like a flammulated owl. Some of you have been through this routine a few times, so I'm going to expect you. I'm going to be expecting some really good calls out here in the audience, in addition to perhaps some beginner calls as well. Everyone, I'm convinced, can master this call. Okay, it's just a matter of devoting the time and practice to be able to do so. And for me, I think it probably, so the ultimate goal in learning this call is to see if you can convince a real flammulated owl that you are a territory intruder, okay, and one that represents a threat to that male's occupancy of that territory. In other words, if you can get that male to call to you in response to the call that you are mimicking, man, you're doing something right. And it's somewhat of an ego rush, for sure, okay? So let's see if we can start that journey. So that call sounds something like, that's about the cadence, maybe a little bit slower on occasion. That's about the pitch, and that's about the degree of loudness. Now, we're in an enclosed room, right? Imagine that we're out in the open forest, and that's the sound and the loudness that you hear. That's a really quiet call. It's actually pretty strange, because it is super quiet, and under ideal conditions on a summer night, on a ridgetop, because this is very steep country, okay? If you're on a ridgetop, sometimes this is a really low pitch for an owl to make, especially, it's the smallest, it's the lowest pitch among any of the owls for their size, okay? Because of the configuration of their syrinx. Anyway, this call can carry upwards of up to a half a mile if conditions are calm and if your ears are trained well enough to hear it. But sometimes you can't hear it any further than, across this room, depending on conditions. And if there's a wind blowing, all hope is lost because it can disappear pretty quickly. Of course, the owls can hear it, but just not the humans. So that call, so you want your lips, in training you to do this, train your lips to make to form the word boop, B-O-O-P. You're not going to form the consonants though, okay? So your lips will do that, but you don't sound it out. Okay? And then the problem is we've got a larynx, not a syrinx, okay? We've got a physical problem in that we don't have feathers, and we don't have all the organs that a bird does. But we can sort of fake it a little bit. And what we have to do is change the quality of what's coming through my teeth right now as a human voice. And we have to try to make that sound as hollow sounding as we can, okay? Because I just said the word boop as a normal human would. It would sound something like boop, 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 okay? But no, it's got to sound boop, 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 because that's what sounds invisible in the forest. That's a sound that's very difficult to track, which is why they've evolved it. They're potentially prey for a lot of animals, okay? So to do that, the only way I've discovered to do that is to try to open your throat a little more widely, okay? And instead of having that air come right through your teeth, try to direct that air up into the top of your mouth, the top of your palate, okay? So that it can sort of resonate inside of your mouth before it comes out, okay? So the evolution of this sound sort of sounds like it's going from to okay, so join in. Okay, keep working it. So generally 3 to 5 seconds between hoots, okay? All right, keep working that. Let's check back in at the end of the session here. See where we've gotten, okay? But I guarantee if you keep doing that, you can do that just like any of us, okay? And it is really a super thing, like my students pick up after a few weeks, you know, once they have worked on it long enough, the first night they go out and the first night that a male responds to their call, it's like, yes, I did it, okay? And things continue to improve, but once you fake out an owl, you fake out an owl. So anyway, we go out at night, we mimic that call because it's easier than playing tapes, and a lot of advantages because you can you can adjust the degree of loudness, the number of hoots that you want to give, especially when you might be hearing a distant owl. You need to stop it. There are a lot of reasons why it's just simple. Much simpler to vocally imitate the call. So we do that at night because what we want to find are where the territory boundaries are. Males will give this call, you know, unprovoked by humans or in response to other owls during the early parts of the summer. As soon as they arrive from migration, males have the potential to start calling and giving that territorial call, okay? And they will continue. The peak of territorial defense is in the first couple of, end of May to the first couple of weeks of June, until egg hatching, basically, okay? And so during that time, males will call at night, sometimes some nights, I swear, some males don't call at all, okay? They're very unpredictable, which is one of the reasons they can be difficult to work with. Some nights, you'd swear that some males never quiet at all. They're calling so vociferously, okay? But if you're out enough, you can track these males. What we try to do once we hear a male calling is to chase them down and to mark the trees that they're singing from. Because ultimately, over a period of nights and weeks, the males will eventually sing from the distant-most trees in their territory. That is to say, the outermost points in a polygon, they will identify for us the area that they are defending. And this is a really important area because everything that a male does, everything that the nesting pair does, is confined to that piece of real estate, okay? The nest will be inside of that area. The male is foraging within that area. He's doing all of his behaviors, including defending the territory from the song posts that are within that area. So we have to find out where these territory boundaries are, because then next what commences is a search for the nest. And that involves searching for all of the trees that have cavities, woodpecker holes, within a particular territory, and marking those. This is a really important long-term investment because trees can stand for a period of time, or they can fall relatively quickly too. But we mark every single tree. We make maps of them in GIS. We GPS their locations and so forth. This is a dynamic resource that we have to add to and adapt every year. But what we will eventually do is go through every single cavity tree with these cameras. There are eavesdropping cameras that are mounted on the end of fiberglass poles that will rise up to about 50 feet, that we attempt to get into every single cavity that's large enough, potentially, to see if it might be the one owl nest that's within one owl territory, never more. Well, only one exception have I seen in reference to that over time, one polygynous male, but basically one nest per territory, okay? So you have to find the needle in the haystack, and that can take a period of time, a lot of time. It generally takes us the entire field season to find all of the nests that might be within the study area, and do that in all of the study areas, okay? This involves daytime work in trying to find out, and check occupancy of cavities. It requires a lot of nighttime work for the attempts to capture the owls and to monitor their progress and the different nesting phases that are going on at night as well. So it takes a lot of effort. That's one reason why it takes a lot of individuals to pull these things off. So once we find the nests, then this involves the capturing and the banding of the owls. Once the owlets are old enough, there's a narrow window of time in which typically I am the one that will climb the trees, the nest trees, okay? And they will nest in live trees as well as snags, standing dead trees. And you can see that small body up there in the tree there. That's about 45 feet up in that tree or so. So they can be as high as 60 feet plus. The average height is generally about 25 to 30 feet, okay? Still pretty high depending. And the cavities that they nest in, generally, if this is the woodpecker cavity here, the cavities generally are 12 to 16 inches deep, sometimes deeper. Sometimes they can be almost a meter deep. But in this picture here, for example, you might see my right elbow is about all you can see of that right arm, because the rest of the arm is inside of the tree, trying to reach the nestlings that are inside of the cavity. This can only happen during a narrow period of time in which the young are old enough to be able to take out of the cavity safely without the female abandoning the nest. That's a very, there are a lot of safety aspects about this, human safety as well as the bird safety that we have to worry about. So narrow window, we get in there when we can process them. If I'm stuck up in the tree, my students are down on the ground. I'll lower the owlets in a bag on a rope so that students can process them on the ground. Massing them, banding them, usually taking a drop of blood, because that's the only way that we can sex the individuals, the young owlets, and so forth, okay? So all of these things take a lot of time, but capturing and banding certainly take the remainder part of the summer as well. Yes, question? Yes. Yeah, so quaking aspen is an important nesting tree for flammulated owls. But it's important to recognize that these are not quaking aspen forests. Quaking aspen, especially here on the east slope, in a lot of portions of the state, not all, aspen is a species that will grow in wet drainages and under mesic conditions. And so we find narrow distributions of quaking aspen embedded within ponderosa pine forests. So aspen in the bottom of drainages with ponderosa pine on the slopes and ridges surrounding those areas. So they'll nest in aspen quite a lot. We find about 75% of all flammulated owl nests in aspen. But actually, that's only because about 75% of all cavities are in aspen. Woodpeckers love soft trees. They don't want to work any harder than they have to make a cavity, even though many of them can drill in just about anything, including the walls of your house, right? Or through the metal of your house. Yes. Potential predators are the ones that they will try to make sure that they steer away from. But at least in terms of other potential competitors for cavities, no, I mean, there are, in these forests where my study areas are, there are generally a lot of cavity trees because these are unmanaged forests, which is why I have my study areas in these areas. From the beginning, I wanted to find where flammulated owls were probably in relatively pristine conditions. So in each study of their area, there are generally 1,000 or more cavity trees in each study area that we have to go through one by one. Anyway, so there are all sorts of cavity nesting birds that will be nesting in other cavities in those trees. And flammulated owls may be nesting in the same tree as a western bluebird, for example, or a pygmy nuthatch, or a red-breasted nuthatch or something.
Just thinking about her question, I was wondering, when you made that little sound, if I'm a big owl, well, the little guys around, going after him. Does that happen?
Oh, sure.
Okay.
Yeah, so there are many potential predators of flammulated owls, including larger owls, long-eared owls, great horned owls, for sure. Okay, and some other large owls as well. Okay, yeah, so we've certainly had great horned owls and long-eared owls go after flammulated owls. We will set up mist nets on occasion during the summer and do playback calls associated with those mist nets to try to capture some owls that are not nesting, for example, because we don't have the focal point to use to capture them at. And we have attracted great horned owls into those net areas that have trashed our nets in the process. But yes, in that call, there's a reason why those calls have evolved to be difficult to place the exact location of the source. And predation is certainly one of the main ones. Well, so against that backdrop, let me tell you a few things regarding their biology that we've learned over time. Family units are relatively small, quite small, on the order of about 2.5 eggs or owlets per family, okay? And by the way, this is a very small range of eggs and owlets that are potentially possible in a nest. That is to say, there are only a handful of times that I found a clutch of one egg, okay? And there are, I think, so over the expanse of time now, I think we're up to about probably 500 plus nests that we found of flammulated owls. You know how many of those have been 4 eggs? Not any more than that, just 4 eggs. 6 out of 500 plus, okay? All of the rest have been clutches of either 2 or 3 eggs only. So it's a very tight range that they will produce, quite in contrast to many other birds I could talk about, where there's quite a lot of variance, and raptors, where there's a lot of variance. Delayed age of first breeding. I've learned that flammulated owl males especially may be as old as 7 years before they might have their first breeding attempt, okay? And so here you start to see why it's so important to band every single individual and track these individuals through time, because otherwise you can't learn these things. Very high survival rates, long lifespans, upwards of 20 years. I think probably about 12 to 14 is the average age of a male in terms of its lifespan. Well, all of these factors that I've described here are characteristics you might associate with a large bird, especially a large raptor, okay? Raptor is many times the size of a flammulated owl. These are characteristics that you would associate with an eagle, great horned owl, or some other similarly sized bird. So I like to say that a flammulated owl is a very large bird trapped in a small bird's body, because these are characteristics that you would think of in that kind of capacity. Well, it's also for these reasons that flammulated owls are of conservation concern, because if populations were to decline in any one area, we know from experience that any birds that have these kinds of characteristics, they cannot recover from population declines very rapidly. Not with that kind of reproductive rate, okay? And not with individuals perhaps having to live 7 years before they can breed for the first time, okay? So there are a lot of reasons to be concerned about them and to study a species like this. Okay, I better get on to migration. So against this backdrop, I should tell you that, okay, so for years, I wondered if I would ever learn in the process of this work where flammulated owls migrate to, okay? Technology finally came through in terms of allowing units to become small enough that we could mount them on small enough birds to do so. But not until about 2009 did technology start to help us in a sense where small songbirds, since flammulated owl is about the size of a songbird, this is when it became possible to do so. And along those lines, there have been a lot of objectives that I've been wanting to uncover or address associated with focusing on migration work. The phonology, the timing of migration, winter destinations for sure, stopover locations. They can't do it all in one flight. So determining where they might be stopping for, bed and breakfast to be able to refuel and so forth are really important things. And something called migratory connectivity. The degree of association between the summering areas and the wintering areas. I'll come back to that also. Well, so these two devices that I showed you in the beginning, I'm going to start talking more about them now. These are the geolocators, okay? The light level loggers. And this is what appeared on the scene first in 2009. And this device, this logger is, it has a light stock on it, okay? That's really sensitive to ambient light conditions, all right? Such that this is battery powered, okay? And every 2 minutes, 24/7, this light stock is measuring ambient light conditions and storing that information on this little device about how much light it's receiving, okay? Well, that's critical because by virtue of that, this device is able to figure out when sunrise and sunset times are, okay? Well, if you know sunrise and sunset times, you can figure out latitude, okay? And if you know the midpoint of the day between the sunrise and sunset, the zenith of the sun, you can figure out longitude, okay? So these are crazy things that ancient mariners used to use to figure out their location. So it's nothing brand new, right? It's repackaged, and it's so that's the cool thing, okay? And this device stores enough battery power to be able to power this thing for generally about, in this package anyway, 14 to 16 months, okay? Which is pretty darn good. Against that backdrop, the so-called negative thing is they're not super accurate, okay? That they're accurate, at least in terms of determining the position of an owl in a tree, okay? Accurate to about, well, I've got that on the screen, right? Plus or minus 100 kilometers. In other words, plus or minus about 60 miles, okay? Well, if a bird is migrating from one continent to another, who cares? That's really, really important information. If you're trying to determine pinpoint locations, well, there are constraints for sure. So first using this in 2009, we have, you can see the data there. We've recovered 12 out of 44 units that we have put out, okay? Oh, so what I need to tell you next is, where is this data stored that I was just describing you of these light conditions and the degree of shadiness? Right inside this device. How are we going to get it? Oh, we have to recapture the owl, okay? We have to recapture the owl 365 days later, okay? Well, easier said than done, okay? Male flammulated owls have a lot of fidelity. I've learned over time that males will generally stay on the same breeding territory their entire lifetimes, okay? So that is a huge that's a huge drawing card for using this technique. But still, the problem is, even if we know a male is returning to the same piece of real estate each year that he's alive, we don't know where he's nesting. That takes time to figure out. And every time these owls get captured, they become much more difficult to capture, okay? Because they remember the experience. They remember what this crazy net is that I'm swinging in the air at night. I didn't tell you this, but that same collapsible pole, we weave on what looks like a butterfly net. It's a wire hoop with a bag made of old mist net material to form a bag, okay? And we will wait for a male to fly into the cavity with prey at night and then swing this pole over the cavity to try to capture that bird when it's leaving the nest.
Is
Okay.
your creation.
Yes,
Okay.
it is. Yeah. And I could tell you many more stories about that, about what I tried first before I landed on this. But some of them are quite embarrassing, to tell you the truth. Anyway, this is the best technique that I've discovered, that anyone has discovered for capturing flammulated owls. But it takes a tremendous amount of patience and time. And under the cover of darkness, we have to keep things as dark around the nest cavity as possible at night to keep from disturbing them, and also to keep the conditions as normal as possible for the male to fly in the cavity. Well, by the time the male flies into the cavity, with this net having to point in a different direction so that the male feels comfortable enough to fly in the cavity, that generally gives you about a second to a second and a half between the time that he flies into the cavity to go down and deliver the prey to the female and the young before he comes back out. Okay, so you got to go fast once you've got the narrow window of time. And even when you're lucky enough, there are many tricks males have learned to escape the net. And one of them is, if we happen to get the net up in time, if it's an experienced male, it doesn't take very long for them to figure out that, well, if there's a net in the way, I'm just going to perch at this at the entrance of this cavity and see if I can wait out how long this net has to stay here. Okay. Well, this is all in the cover of darkness, right? So the human down on the ground is wondering, has he flown out yet? Did he escape and I just didn't know it? Because this cavity might be 40 or 50 feet off the ground. And you can't quite tell, maybe if he flew out of the backside of the tree and you didn't see it. Okay. So it's a waiting game. Okay. Well, so there's the waiting game. And then also males will get into a habit of trying to crawl out the cavity entrance and crawl out this using their talons that are quite sticky on the trunk, and try to crawl around the reach of the net that's surrounding the cavity. And once they get onto that trick, it becomes really, really difficult. If you're interested, you can go to the BCR website, the Birding Conservation of the Rockies site. I wrote a blog for them last spring about the very first owl we recaptured that had a migration device on it. My students kept track of the number of hours we strung together to try to capture that first male that was carrying a migration device. And they got up to 50 hours before we managed to capture that one flammulated owl, okay? So suffice it to say, sometimes we will not be able to capture a male that we know is carrying a migration device. So 12 out of 44, that's part of the reason for the relatively low rate of recovery of units. One of the most important reasons. I should tell you there is also a failure rate on these electronic devices of about 20%. So between what I've described here, there can be multiple things that don't go right. But still, we've got some data that I'm here to tell you about tonight. Okay. Flammulated owls typically will use a different nest cavity from one year to the next. They generally don't use the same nest cavity in consecutive years. A lot of birds will do the same thing, and it's probably an adaptation to avoid parasites that might carry over from one year to the next. Okay. GPS loggers that I started only in 2016. That's when they finally became small enough as a device to be able to use on small birds. Accuracy, man, these blow the roof off of the geolocators, okay? Plus or minus 10 meters, it has been tremendous to look at the detail that we've been able to learn from those. The downside on those, communicating with the satellite takes a lot of battery power, okay? The neat thing is I can program these things before I ever put it on the bird. So I can hook these devices, they can be reused. They've got a rechargeable battery on them, but you can only go on one charge for the whole migration time. So I'll charge it up and I can stipulate what days I want this device to communicate with the satellites. and to achieve a fix on a position, okay? So the downside is there's only enough battery power to be able to get about 35, maybe 40 locations before the battery runs out, okay? As opposed to several hundred that I might get from a geolocator. So the picture I'm painting is that with these two very different devices, it's really good to actually work them both. And that's what I'm currently doing and students are currently doing right now, because they both sort of supplement the deficiencies of the other, okay? Recovery rate has been going better with these. We're batting better than 50% here, which is pretty good. I like to think we're getting a little bit smarter in some ways, but so here's the story. I wanted to show you the picture of the very first owl that was recovered with the geolocator device, this one that was tracked more than 50 hours, okay? This is what it looked like. I won't get into too many details except that the yellow here, the gold, is the fall route, the dates associated with fall migration. The green is the spring, okay? And so this owl left the Manitou Experimental Forest on 21 October, made it down to Mexico on 3 November. These series of polygons, details aren't too necessary here except to tell you that there's some movement around a central point that an owl will engage in for the 2 or 3 months that he is on the wintering grounds. They don't stay in one sedentary spot, although it is a relatively small area. But that green designates the 50% polygon in which that contain half of all of the male's movements during that period of time. The white circle is the 75, and the golden whitest one is the 95% of all locations, okay? And you see the stopover locations as dots in the respective colors there as well. So to learn this from the very first recovered geolocator was something really, really cool. The centroid, the center of this polygon, is centered in the state, the southern state of Michoacan. And let's see, I'll come back to a point I was going to make in there earlier. So of all of the geolocators, the first 4 of which I reported in that 2016 paper, the first one, but these are the other geolocators we've recovered since then, a total of 12 of the units. And so here is Michoacan here. This is where that first unit was recovered right here. And you can see the population of points for the other males we've recovered. Most of these have been centered in southern Mexico. A couple of them in the northern reaches of Mexico, but not very many. They're going farther south, okay? And if I can show you the next, these are all the points associated with the recovered GPS units. Now remember, these are the ones that are super accurate, okay? Plus or minus 10 meters associated with these. 10 of these units that we've recovered. Again, almost all of them centered in southern Mexico, the states of Michoacan, Guerrero, Oaxaca. And the summer before last, we had our first recovery in Guatemala, okay? So, yes, that is definitely the furthest south. And so I know this is happening more frequently than I've been able to discover yet. So this is, you know, one of many reasons why I want to keep this going, because I want to find out how commonly this is and see if they are even further south than in Honduras and so forth, okay? But that's pretty neat. That definitely represents the southernmost point associated with those. So taken collectively, the GPS loggers as well as the geolocators, we see this area here that's associated with this clustering in southern Mexico. Well, let me tell you a little bit of what the habitat is associated with in this part of the world. I've made 2 trips so far. Both of these were pre-pandemic, okay? And I'm trying to get back down there since, and I just haven't been able to do it yet. But these are all in what's referred to as the Trans-Mexican Volcanic Belt area. This is an area of historic volcanic activity, relatively higher elevation as a result of the higher volcanic activity. And the soil type associated with these volcanic soils is just really super for these beautiful pine forests down there. And so one of the things I've wondered from the beginning is how important pine species might be, not only as breeding habitat, but also for wintering habitat and maybe stopover habitat as well. Well, this has helped convince me that even on the wintering range, these pine forests are extremely important. Ponderosa pine doesn't have a distribution that goes this far south, but you know what? Closely related species to ponderosa pine do. And this is sort of the center of the universe of the diversity of pine species in southern Mexico. So there are many species that have the physical appearance of ponderosa pine, long needles, really large, wide tree crowns, which are favored by males for foraging, capturing insects, and so forth, that these other species also have as characteristics of them. So I don't find that too surprising. It's really cool to have learned this aspect about the habitat. And so this is one of the pictures from this part of the country down there. So I think flammulated owls are searching for the same kind of habitat on their wintering grounds as they're breeding in during the summer. Okay? Yes?
Northbound migration took much longer than the southbound.
Well, actually, with the first few recoveries, I was thinking that the fall migration took a lot less time than the spring migration. I've since learned with the full sample, it's about the same amount of time in general, okay? But it is interesting that the spring migration is not appreciably shorter than the fall migration as it is, as we've learned with a lot of songbirds, because it behooves males, this is from an evolutionary standpoint, to get back to the breeding grounds as quickly as they can to stake out their real estate from which to be able to attract females for breeding purposes. But flammulated owls are not doing that, and I'm convinced it's because of the great disparity in weather conditions that we can experience, at least in Colorado, at elevations of 8,500 to 9,000 feet. We can have snowstorms like this last spring. You know, we had some late snows, right? It was a little later this spring, but we can have snowstorms easily until the first week of June, if not later, like we did this year. And that spells doom for an insectivorous raptor like this, to have this long migration route, return to Colorado, probably having used all of their fat reserves, and then have a period of days or nights in which food disappears. That would not be a good combination. So I think males have to wait until conditions are more optimal for them to return. Yes? Yes, they do. I'll show you a little bit more about that here in a moment, but and there's a lot more for me to learn about that. But from what I can sense right now, pine habitat is associated with those as well. Yeah. How about a quick anecdote? So anybody been down to the monarch preserves in Mexico? Be able to see the, man, if you haven't been down there and if it's not on your bucket list yet, I'd recommend that it be on there. This is one of the coolest things in the world to be able to check out, for sure. Especially in light of climate change, we don't know, how long this can continue. But the impetus for me to, actually, I made a trip down there before I had ever put any migration devices on. That is to say, before I ever learned that geolocators were finally in the size for me to use, I got a call from a monarch butterfly researcher down in Mexico. And well, sorry, an email back in 2009. And some of you might be familiar with the name of Lincoln Brower. He's one of the original individuals that was able to find the location of the monarch butterfly preserve, the overwintering sites. Anyway, one of his crew emailed me to let me know that they had accidentally captured a flammulated owl in one of the mist nets that they had set up around the butterfly roost sites, because they were trying to get a sense for how important songbird predation was on the monarch butterflies in these areas, okay? Well, one night they happened to leave their nets up too late, apparently. Didn't get them down in time, and they captured a flammulated owl. So he emailed me to tell me, Dr. Linkhart, you might be interested to know we captured a flammulated owl. And I said, whoa, really? because this has been the first time that the flammulated owl had been recovered or evidence that flammulated owls might be wintering in this area.
do you
So I
ever
went
use
down to this
that?
area and I started trapping for flammulated owls in 2009 down there. And lo and behold, after that fact, I went down there a few years later, and on the basis of these data, you can see that subsequently we have learned that flammulated owls wintering, migratory flammulated owls are wintering in these areas.
So do you have a number of scouts in that area?
Not as many as I would like. Yeah, let me know if you're interested in being part of that. So this is a view of the pine oak forest down there, okay? Beautiful pine forest. Here's a view of the Colorado pine forest. The difference is it's a little wetter habitat, a little more mesic in Mexico, so there's more understory growth. Beautiful diversity of oak understory, which the owls are obviously using as well. But at least in terms of the pine overstory, very strong similarities in the pine trees themselves and the kind of habitat that they're affording flammulated owls to be in. Oh, I should also point out to you that my first trips down there to capture flammulated owls did not capture any migratory flammulated owls, only resident flammulated owls. You might be aware of the fact that for a lot of long distance migratory birds, there are some populations of those species that don't migrate at all. They stay, for example, in the tropics year round, okay? And this is what I've discovered with flammulated owls. Here is a resident flammulated owl that does not migrate, one of the individuals that I captured down there, and they look pretty different from a flammulated owl that migrates to Colorado. They are even orangier. I don't know if you can tell, but look how red-orange that face is. It almost does look like it's on fire. And they're also smaller birds with wingspans that are not nearly as wide as migratory flammulated owls. We have learned from a bunch of other species that long-distance migrants have longer wings than residents that don't travel as far. It's much more energy efficient evolutionary adaptation for flight, okay? Yeah, so here are some other resident flammulated owls that we captured. So in all the time that I've been down there, I've never been able to capture in the mist nets that I've set up a migratory flammulated owl, certainly from Colorado, okay? They've dodged me, okay? I've got all the evidence from the geolocators and pinpoints, but not in hand yet. But plenty of resident flammulated owls. And this is very intriguing to me. I'll talk a little bit more about that. Well, I better be wrapping things up, right? Okay, so how about a few more things? I want to point out a few things about the stopover habitats. There are sky islands. I'm going to call them isolated forests, isolated mountain ranges that I think are really important for the migratory stopovers of flammulated owls. Areas like the El Cielo Biosphere Reserve in central Mexico, a little bit further north, the Maderas del Carmen. There are some bioreserves that are in very steep country that contain these high elevation pine forests that multiple males have been stopping over in the same vicinity on either their trips down or their trips back that I think are extremely important. In the southwestern US, those of you that have traveled to southern Arizona, southern New Mexico, know that these so-called sky islands are really important bird stopover locations for songbirds. I'm convinced now that they're really important for flammulated owls as well. In these habitats, ponderosa pine appear to be at the highest elevations that are possible right now. So that's another aspect that's concerning from a climate change standpoint is, you know, as conditions warm, forests over time have to migrate farther higher in elevation in order to find suitable temperature conditions to match the growing conditions that are required for those tree species, such as ponderosa pine. Northern New Mexico, some low elevation pine forests are also where flammulated owls have stopped over a great deal as well. So I'm convinced these bed and breakfast locations between stops are a really important aspect that it's enabling these flammulated owls to make it to their destinations, either their northern locations for breeding or their southern locations that they're overwintering at. I think I'm going to jump over this for the moment. Phenology, at least in general, they are leaving about the first or second week of October, okay? Arriving in Mexico, generally in the first or second week of November, about a month's time or so. And then departing from Mexico somewhere around the end of the first week of April and arriving back on breeding grounds around the first week of May. There's some variance from this from year to year, depending on weather conditions. And this is getting earlier and earlier each year, as you might imagine, with climate change effects as well. So a few last aspects I'll touch on. These wintering areas in Mexico, you know, they are subject to a lot of, you know, human perturbations on these areas, illegal logging and some other activities that certainly endanger in the long run these destinations for not only flammulated owls, but a host of other songbird migrants that are staying in the winter months in these particular areas as well. Bioreserves, I'm convinced, in those areas that I was talking about a moment ago, are really important stopover sites that function to enable these birds to rest and be able to get food to continue their journeys. One thing I'll highlight about the climate change is I don't think that the arrival and departure dates of flammulated owls are changing. I don't think they're changing fast enough to keep up with the temperature changes that are happening in these habitats. And I have an anecdote clear back from 1983, where one of the first radio tagged males that I lost contact with, this was a radio transmitter, okay? Beep, 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 producing the continuous sound that I was tracking with the Yagi antenna. I lost contact with that individual on the 12th of October, which coincides perfectly with the date at which currently, you know, 30 years later, 40 years later, flammulated owls are showing that that is about the date that they are leaving for migration, carrying these devices on their backs. So there are some other anecdotes to share with that as well, but I'm not sure that the arrival and departure dates are changing fast enough to keep up with the temperature changes. One aspect I wanted to finish with here that I was alluding to a moment ago. I was talking about the resident birds, flammulated owls. The range map of flammulated owls, by the way, needs some updating. and this is something I'm in the process of doing this winter, is updating the maps that we have on the Cornell site and others. We know it's not totally accurate, but something that is intriguing to me is that these resident flammulated owl populations that are not migrating, I can see strong evidence that they and the migratory flammulated owls are staying in the very close to the same habitats and geographic areas over the wintering months when they're both present. This raises some very interesting questions about competition between flammulated owls of very different populations in terms of migratory status or not. And I'm not sure how they're pulling it off. I don't know. It's going to require a lot more effort because we know from an evolution standpoint, this can't happen without something giving. One of the, you know, if they're different species or different populations of the same species, typically what has to happen is when there's a lot of overlap and competition for same resources, one of the species, if not both, have to diverge from each other to make sure there's enough food for them to make it through the period of time of overlap. And that means either adopting different micro habitats within the same area in which they're foraging, or evolving adaptations to associate with slightly different habitats, maybe slightly different elevations within close proximity, to make it through, to make that possible for those populations to coexist in a relatively close area. Right now, I have no idea how they're pulling this off, but I do see that there is potential for some strong competition that no one is, you know, nobody's figured out yet. Pardon me?
Plants do that at different times.
Yes, they do.
Now.
Yes, yeah, in terms of their phenology, yes. Plants and animals certainly show evidence of ways of coexisting that they've evolved into. And this is one of the things I want to figure out in the future. Yeah, maybe I'll hold off on taking questions here for just a second until I finish. Anyway, so going forward, that's an aspect I would like to focus in on. A lot of people to thank here and entities. U.S. Forest Service has been a huge player in all of this research. Certainly the Manitou Experimental Forest, an area for me doing my summer work, has been probably the most stable place in the world where I could have pulled off a 40-year study that would not have been possible anywhere else. And for that, I'm extremely grateful. And a mountain of students that have helped me over time, talking about some of the things I have tonight, as well as some other aspects that I've only touched on. So with that, questions I'm happy to take. Yes. Thanks for reminding me. I'd be happy to. Yes. No, so the reason is, why do they migrate in the first place? And it's all dietary related. These owls feed primarily on small insects. They feed only on small insects, primarily on small moths. And in the winter months, the insects either all die or they enter a state of diapause in which they are not available. So that's really the story associated with a lot of songbirds among insectivorous birds, why they migrate. Oh, so that's another really interesting question as well. Why do they leave Mexico to come north to Colorado to breed in the first place? Perhaps when this behavior first evolved, right? So the answer to that question is, we don't actually know yet for the case of flammulated owls, but for songbirds as well. We used to have the assumption, which is being questioned right now, the assumption that the tropics were the center of the universe. And that's where populations of migratory birds started out, and they evolved to migrate north, for example, into North America to breed and so forth. But that's been turned on its head. Just only in the last 2 or 3 years, there is a lot of research coming out that is actually stating evidence that supports the opposite view, that perhaps at least some of the birds that are migratory started out with a North American distribution, and subsequently some populations evolved to go south for the winter into the tropics. Reasons for which are, take a little bit time to go into, but we don't know exactly all the pieces that are in place for this. But the short answer I might put with that is that competition for limited resources has to be a major player here. Whether the southern hypothesis is the one that's accurate or the northern hypothesis is the one that's accurate, freeing these individuals and these populations, freeing themselves from competition for limited resources during a period of time in which there is a crunch or a limited supply of food available, is likely part of the powerful driver that led to the evolution of this behavior. Yes?
How do flammulated owls compared to other owls as far as the way their feathers are shaped? Are they any different? Like their hearing or sensitivity to certain things, or eyes? Are they different?
Question is, are the adaptations of flammulated owls very different from other owls or other birds in general? Some aspects, in terms of the configuration of feathers and so forth, no difference, okay? No difference. One of the most important differences that I spoke about just a little bit ago is how long the wings are that have evolved in response to a bird that has evolved a long distance migratory way of life. Longer wings are much more energy efficient in terms of numbers of wing flaps, the amount of air displaced by an airfoil that's trying to stay aloft. So the length of the wings is a major factor. Flammulated owls have very keen ears, very keen eyes, but I'm not sure they're any more keen from what I know compared to, say, some of the other nocturnal owls, okay? And to be sure, there are other nocturnal owls that have a degree of hearing, a developed sense of hearing, that's probably even more acute than flammulated owls. And anytime you see a strongly developed facial disc on an owl, a parabolic disc, that's strong evidence that there's a huge reliance on hearing, for one thing, If you look at boreal owls, if you look at great gray owls, it's crazy how well developed that is. And some of you might be familiar with the aspect that their ears are actually asymmetrical, which means sounds that are coming from the environment are hitting one ear before the other, and the brain is able to process that very minute difference in timing to figure out the exact location of prey. Flams are highly reliant on sight, augmented with sound, because they do, as evidenced by a facial disc as well. Yes.
Let's do Patty's question, then we'll jump to the two online, just so we don't
Okay.
forget them.
Yes. Yeah, good question to ask. The question is, have I seen evidence of populations staying stable, increasing, decreasing over time? Unfortunately, the answer is I don't know. I don't see evidence. It's a difficult question to answer about whether there's an increase or decrease. Here's why. I only have a few finite study areas that my students and I stay on top of. That takes all summer, by the way, to stay on top of. But they're surrounded by other areas where flammulated owls are, okay? So if you could make the case that the area where I study flammulated owls is really prime real estate, we call them source habitats in biology, then these would be areas that you would expect to always have a lot of flammulated owls on them over time. And I have seen these study areas remain with relatively high numbers of flammulated owls, dense populations of flammulated owls over time. So that's one perspective, is that these owls are producing a lot of owlets every year, really good habitat, that are going out into the world and filling habitats that are not as desirable. But I can't discount that from the opposite view that, well, what if these are actually not source habitats, not the best real estate, but the poorest real estate, theoretically, okay? I wouldn't be able to tell the difference, because then birds from other habitats that might be better would be coming in to fill these available places. And what would be the end result? Seeing flammulated owls in these same areas every year. So without studying the larger universe of flammulated owls, it's a really tough thing to address. And unfortunately, this remains the only intensive population level study on flammulated owls in the West. There are other, yes, there are other areas in which flammulated owls are being studied, but not studying reproduction and survival over long periods of time. So we don't have any idea about the population characteristics in other areas.
Let's
which
let
needs to be known.
Courtney online ask her question, because she
Okay.
shot her hand up right away.
Okay.
Hopefully she's still there.
I am still here, and does that mean that I can
Oh.
do a couple?
Let me plug this back in real quick. So,
Oh, okay.
sorry.
No worries.
All right, we should be able to hear you now, Courtney.
Okay. Am I audible now?
Yes.
Cool. Thank you so much. That was amazing. I've known minimal things about flams until today. I'm staggered about the age of the males. I would have expected less than 10 years, like screeches. So first question is, I've seen that you've mentioned a lot of data with the males because of their sight fidelity. What have you been able to obtain about the females, even though they're not, I guess, loyal to the same sites? Or do you
Yes.
specifically only tag males?
Great question to ask. And the short answer is I know less about females than I do about males, okay? It's really been tricky because of the lack of fidelity on the part of the females. What we see is that females are really prone to divorce, and that's what we call it in the bird world. Females are much more likely to leave their original territories and the males that are part of them, part of those areas. And in a subsequent area, if they're still alive, they'll go to another territory, okay, and breed with another male. What I've actually, there's a lot of interesting aspects I could go into. One thing I'll share with you at the moment is, one thing I've discovered over time is that females are typically in a process of upgrading males and territories over their lifetimes, okay? So they are prone to divorce, apparently because they are trying to opt for a male and territory that are better than the ones that they had in the past. What do I mean by better? These are territories that over a long period of time, I keep track of the total number of owlets that each territory produces over time, okay, over the 40 plus years. And I can tell you that on average, females, when they do change territories, they're going from a territory that has produced fewer owlets than the territory that they will move to, okay? So females are upgrading, and you might ask the question, well, how do they figure that out? These territories that produce more owlets are also territories that have larger stands of older ponderosa pine on them. So I think the forests, quality of the forests are driving a lot, and females, through whatever mechanisms, are figuring this out. I could tell you how I think they do that, but maybe that's another question. Anyway,
so you are still tagging the
short
females,
answer,
I guess?
pardon me?
So you are still tagging the females, it sounds like.
Well, females are always banded, but I don't typically put migration devices on females.
Got it. Okay.
And the
That makes
reason
sense.
is because I think females have shorter lifespans than males. I've noted that the fact over many years, there are typically bachelor males in the population during the summer that breed and are unlucky to get females, okay? Which suggests that there are fewer females that are available for breeding purposes than males. And also for the females that I've tracked over time, they appear to have a shorter lifespan, a shorter time on the study sites than the males do as well. Long story short, I've opted not to put migration devices on females because I have not wanted to impact the possible survival aspects that these devices might have if they're placed on females. So over the last 10 years, I opted to go with males that are more reliable to find and have documented long survival times to find out as much as possible about migration before wanting then to see if I could expand this to include females as well, okay?
Got it.
So
And my
I haven't
last
included
two-part
any
short
females in
question. Oops,
migration
sorry.
devices.
Okay, thank you for that. Last two-part question, but it's very, very short.
Okay.
One, does this data feed into OwlNet? And two, are there any other flam researchers in the US or along the Front Range aside from you?
Sorry, I missed that very first part.
Oh, does this data feed into OwlNet?
Sorry, does what happen in the OwlNet?
Does the data that you're collecting
okay.
for the flams feed into OwlNet?
Yes, it does. It does feed into
Oh, cool. Okay.
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 I already forgot the second part. Sorry.
If there are any other flam
In the
researchers
state,
along
no.
the Front Range
No
and
other
in the US?
flammulated owl
Okay.
researchers in Colorado.
Got
There
it.
are a few in other states, Utah, Oregon, Washington, California, but typically these are associated with master's degree studies, and so they typically only go for 2 years or so before they're over. Yeah.
Thank you so much.
Sure. Yes. Good question to ask. That's certainly something that I've had my eye on over the years. So we've been collecting DNA on owlets for about 15 years. And over that period of time, it looks like there is about a 50-50 sex ratio out of the egg. So that suggests if there is a difference in survival, it's happening after they hatch. And here's what I think is going on, if I can cut to that. Females produce a clutch of eggs when they're adults and they're breeding. They produce a clutch of eggs that is about 50% of their body mass. Each egg weighs about 10 grams, okay? So if they lay on average a clutch of 3, which is more often the case, that's about 30 grams. Females weigh on average about 60 grams as adults. So 50% of their mass is going into egg mass every year. And when are they, and by the way, this is one of the highest percentages among all the North American owls, percentage of body mass going into the egg clutch. And when are they producing this clutch of eggs? Oh, right at the end of a long migration. Within the span of about 10 days, they're producing a clutch of eggs. So I think energetics is at play. And I think that females are, dealing with a very tough energetic expense associated with the migration, then followed by the breeding expense. It's tough being a male too, I'll tell you that. I mean, they put a lot of energy into foraging, and they will transport one insect back to the nest during the breeding season, one insect at a time. We call them single prey loaders, and they're only carrying one small moth at a time. Okay, that's a big energetic expense, but still, it probably pales compared to what females are up against in terms of this energetic expense. So I think there's a different survival rate among males and females. Yes.
What size of your range, like a mile, a blah, blah, blah. And then you had, one of the first slides, you had the fire area, is that an area where you find them?
Yes, it is. So two-part question. First question is about how large is a territory or home range of a flammulated owl. And so the area of that is, it's about 15 or 20 hectares, which translates into about 50 acres. Stated another way, this correlates to about 15 or 20 soccer fields, okay? But these are not flat soccer fields. This is very steep terrain, and so these territories can occupy quite a range of elevation gain in their territories. So this is pretty large for a small bird, on one hand. On the other hand, it's pretty small for a raptor, okay? The Hayman fire, question of whether or not we are still doing work in the Hayman burn area, yes. A lot of interesting things I could say about the Hayman burn. I wish I had had the foresight to study the habitat within the Hayman burn before the burn happened. I don't, but I did start immediately after the burn, as soon as we could get in, because I was interested in trying to determine whether flammulated owls, I knew flammulated owls occupied at least part of the area that the Hayman burn burned through, because I had just vicariously found some nests and so forth in such areas. So after the burn, I was interested in trying to determine whether owls would return to the areas that burned, territories that burned. Would they return to these areas, and would they attempt to breed in these areas again? Long and short of that is that flammulated owls have returned to portions of the Hayman burn, but as probably a lot of you can appreciate, the Hayman burn, there was a lot of high severity burn that cleared out big sections of entire forests. There are also islands of surviving forests, and that's what they are islands. I'll call them low burn, no burn, because the fire skipped. When it was burning at high intensity, it was moving so fast that it would hop and skip over particular areas. The size of these islands of low burn, no burn is where we have found the territories of flammulated owls post-Hayman burn, okay? And they have returned to those areas. But the thing, and by the way, so on the one hand, these owls that have returned to the Hayman burn to breed have produced family sizes the same size. They have fledged the same number of owlets as what I've seen in the unburned forest, like the Manitou experimental forest. The caveat is that because even in the Hayman burn, I'm tracking these individuals through their lifetime. And I've been able to find that Hayman burn males, especially females also, return much less frequently and at a much lower rate than they have in the low burn forest. Well, why would they be returning from one year to the next at a much lower rate? One of two things. They're either dying and not returning. That would be one reason why the lower return rates, or they are showing much less fidelity on the part of males to their breeding territories compared to what we see in the unburned habitats of the Manitou experimental forest. I don't know, you can't distinguish between the two. Either way, it's suggesting that these are suboptimal areas and are areas that are not likely able to support viable populations of flammulated owls in the future. Because these are islands to begin with, and males are not likely, and males show no tendency to stay there for long periods of time when they do return to these islands to breed. So this does not bode well for future large burns that are going to be happening in the West and clearing out habitats. Because as we've seen in the Hayman forest, sorry, you touched a nerve on me. But you know, if you go up into the Hayman burn areas, you can see that it's going to be a long time before ponderosa pine forests return to these areas. Easily a couple hundred more years. And these areas have basically lost their capability of supporting not only flammulated owls, but flammulated owls are emblematic of other species that are adapted to ponderosa pine forests as well. So, yes. Sure. Yes, Paul.
I just had a question about that.
You have the ducks, no things that are CNP.
Time of day that the migration flights occur, does that area?
Question about the timing of the migration flights, and does it differ between the southbound versus the northbound? Short answer, I don't know. Very short, right? I have no experience watching flammulated owls migrate, nor has anyone. And it's a tough thing watching them at night. You know, at least with songbirds, for birds like thrushes and warblers that might migrate at night, we see huge waves of them that we can detect on radar and so forth, right? Which is pretty cool. But flammulated owls don't have that kind of density where we can even have the capability of tracking their movements at night. I don't know whether they migrate singly or in groups. I have no idea what the young flammulated owls are doing. Young flammulated owls, the young of the year, are leaving a few weeks earlier than the adults leave the study areas. I know that, but I don't know. We know a lot of animals that have no experience in migrating to get to their destination just by virtue of what's evolved as instinct in the brain. But I don't know how young flammulated owls are doing that. I don't know whether males and females are migrating together of pairs, okay? And I know nothing about, you know, the relative comparison between males and females from fall to spring either. I can tell you that I do know from some experience that the approximate distance that males are migrating on each day. And that's generally between 300 to 500 miles a day. Okay. And they'll go for several days before they take a bed and breakfast stop, typically. Yeah. Is there any suggestion based on suitable habitat and available food sources that flammulated owls could breed in any of the Stopover Sky Islands, Guadalupe, Davis, the Chisos Mountains? Whether they could breed. We don't know is the short answer to that. That would be, I need some more students involved in the work to be able to post them in these other habitats. I suspect there may very well be at least some flammulated owls that are breeding. You know, in the north of the border, in any of these southwestern states, Colorado, New Mexico, western Texas, Arizona, and so forth, all of these sky islands and the pine habitats they have in there, I think are quite suitable, at least portions of them that are old enough, quite suitable as breeding habitat. I'd be surprised if there aren't at least some breeders in these mountain ranges that you've identified. You're welcome. Thanks for coming. Thanks for the great questions.
To take home with you
Oh,
tonight. I'll hit
thank
like,
you.
So if you're okay answering a couple more questions, or if you need to go, it's okay to let folks know that too.
Okay.
Thank you.
Thank
so
you.
much.
Sure. Sure.
We were in Mexico